Hello and welcome to today's episode of Rawkode Live on the Rawkode Academy. I'm your host, Rawkode. Today we're going to be taking a look at Litmus, a chaos engineering project for Kubernetes. Litmus has a 2.x release coming up, and we're going to see some of the new features available from Karthik, the maintainer of the project. Before we dive into that, there's just a little bit of housekeeping. First, if you've not subscribed to the YouTube channel, now would be the best time to do it. Click that subscribe button and feel free to tick that bell. That just means that you will get notifications for all new episodes of Rawkode Live. And I will do my best to make sure we cover as many cloud native technologies as possible to guide you and help you on your journey into this vast ecosystem. If you want to come and chat with other cloud native enthusiasts about Kubernetes, cloud native, and anything in between, we also have a Discord server available at rawkode.chat. Come in there, say hello, and I look forward to meeting you. I also want to thank all of the people that have now become members of the Rawkode Academy on YouTube. You can do so for as little as $1. This just supports the channel. There's also other tiers which will get you interactive courses which launch this week, and a very special tier just for the corporations out there that also want to say thank you. So check that out. Very much appreciated. Now, we're going to move on to introducing Karthik, a maintainer of the Litmus project. Hey there, Karthik. Welcome back.
Hi, everyone. It's great to be back on Rawkode. I think it was an awesome experience the first time where we talked about chaos engineering and the evolution of cloud native chaos engineering, and really happy to be back here. Thank you for having me, giving me this opportunity to talk through the upcoming 2.0.
Yeah, it's my pleasure. I had an absolute blast learning about Litmus the first time, and I'm really excited to see what new things you have coming from the project. But just before we dive into that, for anyone who didn't meet you the first time around, can you just give us a quick introduction to yourself, who you are, and what you do?
Sure. I think this is wonderful again to be back here. I'm Karthik, one of the maintainers of the LitmusChaos project. It is a CNCF sandbox project. And Litmus is a cloud native chaos engineering platform, I would say. And it helps you to practice chaos engineering on Kubernetes as well as on pre-Kubernetes infrastructure that you might have. That's how we're calling it today. EC2 instances, GCP, Azure VMs, or your VMware VMs in your data center. You can go ahead and practice chaos engineering. Chaos engineering is not just about injecting faults. It's a lot about hypothesis, what you expect in the system when you're injecting a fault, and being able to derive meaning out of an experiment, learn new behavior about your systems, and not recklessly taking it. So we talked in the last episode on Rawkode about what chaos engineering is and what it is not. We will dwell on that a little bit today, and I'm very happy to introduce the newer version of the Litmus platform. We are primed for the launch of the next release 2.0 later in August, and this would be some kind of a technical preview of some of the features there. Thank you to a lot of the members in the community who have been actively testing it and providing your feedback on the beta that we have out there. So yeah, looking forward to interacting with you all.
Awesome. Just to clarify there, this is a preview of Litmus 2. It's not out quite yet, but it's going to give people a good taster of all the awesome new things that are coming down the pipe. All right. Awesome. Okay, so do you want to talk about some of these new features first, or would you rather just show us it in action? What would you prefer, Karthik?
Yeah, I'll probably give you a couple of pointers. I think as we go along doing the demo and talk about a history of how that feature came about, what requests in the community actually gave rise to that feature, and what we're trying to do with it, and where we're going next. 2.0 is great, but I'm sure there are a lot of things that are not there in the platform yet, and the community is still looking forward to them, so they will come in releases after that. So we'll just talk about how things evolve.
Yeah, okay, sounds good to me.
Cool. So one of the things we started out doing, I think with Litmus, 1.x. That was the version we started up with a few years back, mainly to test OpenEBS. So OpenEBS is another CNCF sandbox project which provides a containerized storage solution, and you could use it to run your stateful workloads. And when we were building OpenEBS and we wanted means to test its resiliency, we thought we should have some tooling that gives you the same experience as people had using OpenEBS or using anything else on Kubernetes. So everything is declarative, everything is a resource in Kubernetes, and you have controllers to reconcile those resources. And people are used to that model or that particular paradigm of running their operations on Kubernetes. And all your policies, all your resource details, the applications and its lifecycle management, infrastructure, everything is declarative, managed in Git, etc. So when we wanted to do chaos in a similar way, we didn't have the solution right at that point of time, and we're talking about sometime late 2017 to mid 2019 period. So we came up with Litmus, and the intent of Litmus 1.x was to provide chaos experiments or simple fault injections, which you could define in a YAML and which could be carried out by a Kubernetes pod or a controller, in other words. And after we achieved that, we got to know that there's much more to chaos engineering than just being able to define a fault. You must be able to define the blast radius for your experiment. What is it that you want to impact? What is it that you do not want to touch? How restricted should your experiment be? And then we came about the necessity for automating these experiments in a good way or schedule them. Sometimes you want chaos run in random fashion. Sometimes you want it to run in a strictly scheduled or sequential way. So it sort of, and one of the things we learned as we went along is while chaos engineering as a discipline has its very solid principles, or as you can say, um, principles tested over time by all the SREs, that you need to be able to run in production, you need to be able to run varied events, etc., etc. While all that is true, we found that people practicing chaos generally often tend to use the tool in mixed ways. They use it as a testing tool for carrying out simple failure testing with very, very predefined expectations on what happens when you run a fault. But they also can use it to run things in a freestyle, exploratory way where you're learning about the system. You don't have, you basically don't have a set expectation. You're just trying to see what is happening. Of course, you have some hypothesis, but then you're okay to learn about it, and you're doing it in an environment that is very close to production, but not production itself. All this evolution around shifting right, testing in production is great, but after people started adopting the cloud native paradigm, started re-architecting their applications, testing out Kubernetes as their deployment environment of choice, there were too many things happening at once, and people were or organizations were not confident to carry out chaos only in production, but they still need chaos to test out the efficacy of what they're trying to build. So they want to do it in pre-production environments, and and when they are doing that, they wanted some aids, uh, things like probes, for example. You're carrying out an experiment, you're injecting a fault. You also want to see what is happening as the fault is getting injected. And that what is happening part might not be manual all the time. We're talking about observability here. People might be looking at their, peering into their observability dashboards and getting information, but sometimes they're just running it as a background service, injecting faults at random times or at scheduled intervals on their clusters. They also want to factor in what's happening in their environment, even as they do that fault. So that needed to be built in into the experiment itself, the steady state hypothesis validation. So that was another interesting thing. So we've talked about blast radius, we've talked about steady state hypothesis coming into the experiments, then the need for being able to schedule it and run a background service of sorts. So these are new things we learned or new requirements we got as Litmus was being adopted in the community. And then we had a very interesting requirement that came after that to basically say, okay, I have a fault, but the fault is very complex, or rather, I wouldn't call it fault. Let's say it is a situation that I've encountered in my environment, and that situation came about as a result of some failures happening over a period of time. So it's like built up over a period of time. You can call it chained failures. Maybe you had a node that sort of went into degraded state because of some maintenance activity. Then you have the other node, which is probably carrying more load, or your pods got rescheduled there. And then you're hitting a resource exhaustion problem on that node. And you have fewer nodes to work with. You already have one in degraded state. So your applications will take time to get scheduled. There will be evictions. All these kind of problems sort of get built up over time. So let's say we're to simulate those kind of scenarios. How can it do it? Um, with Litmus, when we started out, we were able to inject faults, standalone faults at a given point of time. But now we needed the ability to string together multiple issues or faults to give a larger scenario that you could experience and then find out how your infra app is behaving. So that gave rise to what we call as the workflows in LitmusChaos. We did get a glimpse of it in the last Rawkode discussion as well, but today we will just elaborate on it a little bit more and show you the different ways of creating new workflows. Then all this was great. Now I have decided to practice chaos. I understood what it is and all that, but there are a lot of clusters that I had, a lot of test or staging environments, as you can call it, dev clusters. And I find it tedious to go and install a set of microservices on each of those clusters and then carry out chaos and individually monitor them. I would need something more simpler to do it. That's when I brought in the Chaos Center or the Litmus portal, as we call it, where you can attach other clusters or register them into the portal, and you have some agents residing on those clusters to carry out the chaos process and give you some visibility from a centralized location. So these are requirements that came in organically, sort of not exactly in the sequence that I'm talking about right now, but these were things that we gathered from the community and we built in. And since there were a lot of changes that went in, we thought it's worth doing a major version upgrade. Litmus was 1.2, 1.3, and so on, and we hit 1.13. And then we thought, okay, there are a lot of changes coming in, so we should move it to the next version and do a major version upgrade. So the version upgrade is sort of reflects or is a notion of features rather than being a completely all new version of it, which doesn't work with what was already there. It's completely backward compatible. People can continue to use Litmus with purely the operator and the chaos resources as they were. But the portal is probably something that we will invest time on to make it easier for folks to carry out chaos engineering in a simpler way, in a scalable way, etc. So, and all the new features that I talked about, some of them are directly implemented within the portal, and some of them are not really portal related. They just went into the infrastructure itself, the backend orchestration infrastructure of chaos itself. So these are the things that we will try to go through today in some detail. And I've just pulled up my demo environment, um, which I created some time back. So there might be some real chaos that we might see naturally happening. So I hope the demo gods are with me today. So with that bit of introduction, let me share my screen.
Yeah, awesome.
All right. So this is the Litmus portal, and let me just log out to start afresh. And let me pull my Lens IDE, which I'm using, and I have sort of added these clusters into the lens just to show you what are the pods that are running, what are the microservices that are running as part of the Litmus 2.0. While this initializes, let me just log in. Admin and Litmus are the default credentials. I'm logging in as an admin. You can create different users now with Litmus portal. We call it the Chaos Center. And so this space, this dashboard that you see um, is the first page that you're going to encounter, the home page, which tells you some past history, some past workflow runs, what are the agents that have connected here, etc. And also gives you an option to schedule new workflows. And I think my lens is up right now. So let me go ahead and show you what are the pods that are running. I have the Litmus namespace here. You can see these pods. Out of these, the Litmus portal server, the front end, and MongoDB from the control plane. So this is what is powering this portal. This is just one of the components, the web UI, which is called the Litmus portal front end. The server is a GraphQL server, and it also has an auth server embedded within it. And there is MongoDB to store all your chaos operation details. And what we have here, the other ones, the exporter, the operator, the event tracker, subscriber, workflow controller, these are part of your agent infrastructure or the deployment that will run in the environment where you want chaos performed. So you could have just these three components with the checked boxes to run the chaos center. And you can go ahead and add agents which will run the other unchecked, the components with the unchecked boxes. So the operator is at the core and reconciles the chaos resources, the chaos engine, the chaos experiment, etc. So chaos experiment is a template that describes the fault. The chaos engine is the one that maps an application instance or an infra component with a particular fault, and also provides scope for defining the steady state validation and other run properties. The subscriber is the one that speaks to the portal server and helps track progress of workflows in the portal. And the workflow controller here is an Argo workflow controller, which is the one that is helping us execute the workflows of the steps within a workflow. We chose Argo because of its immense capabilities in sequencing or ordering actions within a workflow. So you could do things in parallel, you can do in sequence, and you can define a lot of other characteristics. You can do cleanups, conditional retention of pods, a lot of flexibility. So we didn't want to reinvent the wheel, and we've brought on Argo as a workflow engine. Of course, instrumented with some Litmus images, so we understand Litmus API. So this is an add-on. There might be other ways of running workflows. Maybe there's going to be a native way of running, of doing Litmus workflows. There will be other tools that one might want to integrate with Litmus over a period of time, maybe Tecton. You never know. So the architecture is being modularized to add workflow controllers of choice. So right now, by default, we have Rawkode that's coming up in 2.0. And exporter is a Prometheus exporter for chaos to show chaos metrics. Event tracker helps in event triggered chaos. You could set up some policies on when you want to run chaos experiments, maybe based on some actions on your cluster. Let's say when you upgrade an app, you want some sanity runs, and you could set up an event tracker policy to identify that there has been an app upgrade, so we basically got a large chaos. What chaos to do there is something that you can describe via annotations. So that's something that we can take a look later. So the Litmus agents is the concept we were talking about. There's something called self agent here. So the self agent is the represents the agent on the local cluster, that is the cluster where the chaos center has been deployed. So it automatically registers itself as a chaos environment. So you can start doing chaos against microservices living inside of this particular cluster.
Yep.
And I have another agent that's added here. I'll show you the process of adding the agent later, which is another cluster which has only the agent components, and there's a Kafka stable set running there. That's the demo that I think we covered in the last Rawkode episode, so I'll probably not do the same demo, but I'll just show you how you can connect an agent. Now, let's go ahead and take a look at some of the other sidebar items and what the improvements have been. So there is a Chaos Hub. So this is the integrated or embedded Chaos Hub within the portal. You know about the Chaos Hub. It is some kind of an open marketplace that has the experiments or faults listed, and they are categorized by different categories, by different kinds of classification. The generic experiments are the standard Kubernetes pods, resource, network, or pod level faults. Then there are AWS categories, and then there is application specific categories, and you also have VMware experiments that we sort of added. I will talk about chaos against non-Kubernetes entities from the portal, which is something that is new, something that we improved upon since last time. So that's one feature. Going back to talking about the hub, you can connect either a public chaos hub or you can connect a private one as well. Let's say you have some kind of an air-gapped environment you're operating out of. You can connect to local Git repositories. It just needs to have experiment entries within that repository in a particular directory structure, as you can see in this repository called as the chaos charts. So the chaos charts here is the canonical backend for the hub, and it has all these experiments listed inside the charts folder. These are not the Helm charts, we just call them the Litmus charts. And each of this is a category, and you could go inside that and find the individual experiment. Each experiment in each category is defined by some information placed inside of the chart service version YAML file, which provides a source for all the information rendered on the card on the hub. Very similar to the way Operator Hub is built, we took inspiration from that and created something that's very similar with chaos charts. You could fork this and place your own experiments and connect it as a private chaos hub as well. You could use experiments from here to pick and create new workflows. So that is a new development that we did here. And this came about as we were working with enterprises and organizations which prefer their own sources. Of course, they would commit stuff into upstream chaos hub when they're comfortable with it, but you would have local sources to run experiments from. The other capability came in the form of the analytics dashboard. So one of the requirements we had is to be able to ascertain the progress we are making in our chaos practice. Let's say you ran some experiments against some microservices. You got a result, and we would need to be, and we would want to compare our results over a period of time. How would you do that? How would you put a metric or a number against the experimentation process that you did? So we have something called resilience score. I think we touched upon it in the previous episode. There have been some improvements there, so we'll talk about it when we get to running the workflow. So you can compare workflows here in the workflow dashboard tab of analytics, where you're essentially comparing different workflows that you ran over a period of time, right? And what scores they achieved, what resilience scores they achieved. And there's also capability to do application monitoring, not so much analyzing results, but looking at how application changes, behavior changes as we go along. And this is something very similar to what you would do with, let's say, a Grafana CloudWatch or something like that. So you have a data source. We support Prometheus today, so you can connect that and you can create a very simple application dashboard. It uses Plotly, and the JSON structure for the dashboards are very similar to how we would construct Grafana dashboard JSONs. We have some features coming in close to our code that will help with creating new panels or creating new dashboards from the portal, but today you need to sort of construct and then upload them. So that's the improvements that we made in the analytics section. So that's something, and we got that requirement because there are folks who wanted to sort of view what happens to their application within the portal without having to move to, let's say, a different application or different browser to open up some other app. Um, how much you use this is left to the user because a lot of people already have observability infrastructure in place. They already have application dashboards set up, and they would only need metrics from the chaos framework to be able to correlate what's happening to application when you sort of consume metrics from the Litmus side. But for folks who've not really set up something uh, already, maybe they can use of the make use of the application dashboards. It also has more intuitive data corresponding to the chaos. It tells you when a chaos experiment started, ended, what is the score, etc. When you hover on the graphs of the applications. So that's something that we added in recent times and something that continues to be improved upon. So as far as the settings goes, this is a standard accounts page where you go ahead and set your preferences. Next one is for teams. So one of the useful features of the Chaos Center is about how you can invite other folks in your organization or in your team to collaborate with you on chaos. So you might have people looking at results, or you might have people constructing new workflows and running them. You might have people just gathering some stats, etc. So you can create users and invite them into the team in different roles as editors, as users, or of all types, and you can collaborate with them
Yep.
for chaos. The other feature here is for GitOps. This is something that we created in recent times. So this is very interesting, and we sort of wanted to apply the best practices of GitOps that's being used for app delivery into the chaos engineering practice. That was one way of looking at it. One requirement that we sort of encountered. The other one was how do we integrate with the standard app delivery GitOps flow? So you have Argo CD or Flux or Key or any configuration management Spinnaker you've set up, and there is a change in the source of your application that, or maybe there's an image that has been pushed. You've set up some automated monitoring and upgrades. So your tool is basically going to go ahead and sync your source with the cluster. It's going to go and update the cluster with the latest version of your app. And when you do that, sometimes you might want, especially when you do this in staging environments, which is probably where you might first apply the GitOps upgrade, the flow, before you promote it to production. So when you do that, you might want to run some sanity checks on an perennially present staging environment which mimics production. You might want to see how this new change in your application works. How does it hold up against different kinds of failure scenarios? So you could run something like a sanity test, and you could create event tracker policies. I think we mentioned it when looking at these deployments a few minutes back. You can set up some policies to ensure that your application undergoes some chaos, predefined chaos workflows that it can subscribe to via annotations, and you will get a result of that and help you to take a better call on what to do next, whether you promote this to production or you go fix something, etc. So the first part of the GitOps story that we mentioned is about workflows that you create which get synced into a Git repository. So if I go ahead and enable GitOps and I basically say this is the Git repository where I want my chaos artifacts to be sourced. I mean, to be placed as a golden copy. So whatever workflows that I create here get synced there. And these workflows, which have been synced to Git and maintained, can then be subscribed to by some application residing in your cluster by means of an event tracker policy. Though it's not really mandatory that you need this always stored in Git, the artifact stored in Git, to be able to pull them and run for as part of your event trigger chaos. It is still good to have it so that let's say you make changes in Git, the same gets reflected on the portal. Next time the chaos runs in an automated fashion because of your event tracker policies that you set up here in the latest version of it. So that's the advantage you would get. So these are the various settings, and there's another tab here. It's mostly for a day two purpose. People who are running in their own run their own registries, which is most likely the case today. You might want to replace the images within a workflow with images coming from your registry, so you can do changes. You can make some custom changes to the workflow just before you run it. So that's to ease up, maintaining your workflows. So I think these are the various features. There's something called usage statistics here. It's more for a high-level overview of how your chaos engineering practice is going, how many users you have on the platform that are participating in chaos, how many projects are there, mapped to what requirements or what teams or what services, and then how many agents do you have, how many workflows you've run, how many have succeeded or how many have failed. A lot of the statistics can be viewed and downloaded as reports for you to give you some kind of information on how things are going. And yeah, so we have our API documentation, which is basically going to help you to utilize this platform without necessarily using the dashboard. So that's the refurbished portal dashboard for you that's coming up. At this point, I'd like to see if there are any questions before I talk about the latest pace of running workflows. And we will have some sample applications, some sample microservices apps that we'll use to run these workflows. So are there any questions at this point?
Yeah, I've got a couple of questions, and we've got one in the chat that's about getting started with chaos engineering, so we can tackle that as well. But we'll start with the changes to Litmus first. So this new ability to control agents and remote clusters, do you see this being the standard way now for people to really adopt chaos engineering by having like a centralized chaos center and reaching out to those clusters? Or do you see a world where it's really just personal choice and people, will still prefer to go down to deploying each chaos center into their own clusters? I mean, what's your opinions on that? Is there a better way there?
It's a great question. I think these are, or the way from our community interaction, we see that there are different personas. Using chaos engineering has become sort of popular, really popular in the last, let's say, year or so. Not to say that it's not being practiced earlier, yes, it is, but somehow there was this perception that it is, there's a dedicated group of experts sitting somewhere carrying out at game day the SREs who really are the ones doing chaos engineering. That from that perspective, it is sort of changing. More people getting involved at various levels of the organization or various levels of app delivery, I would say. There are these SREs who are doing it in a very controlled way. The game day is still the very popular way of doing it. Then there are other folks, let's say QA engineers, who are looking at it, who are looking at chaos and sort of adopting it as the de facto way to do exploratory failure testing, if you will. So the definition of chaos engineering is becoming a little bit broadened, I would say. It's more like the principles of chaos are being applied at different stages. And therefore, the consumers of the tool that provides you the chaos engineering capabilities are multifold. And some of them like a centralized approach to managing chaos. So they have this mandate and they have this autonomy, and they say you have this clusters. These are our staging environments. You are a group of folks who ensure that all services getting onto staging need to be good, need to be validated, and we need to be able to derive some meaning out of that validation. And there's a single place from where we need to collect all that info. I think for those kind of folks, the secure center is useful. But like you said, there might be practitioners of chaos, more nuanced practitioners of chaos, who might think, okay, I'm comfortable doing things as Helm charts and templates. I manage everything by myself. I choose to do it on specific clusters as a standalone deployment or installation. And I'm able to make observations myself and probably have my own tooling to glean results from whatever chaos results or other data that you're putting out and need not be packaged a certain way. I don't need any help in inferencing data. That persona also exists. And the way we see the portal or the center is, of course, it has a UI component, the dashboard, but there are APIs. There's an API server, which is pretty useful and becoming more powerful in time. So you can do a lot of things using CLI or directly invoke API. Maybe you have a GraphQL client in Python or Golang that you're making use of to construct useful faults, run things, maybe consume analytics data, etc., set up GitOps, etc. So to answer that question, to summarize, I think both will coexist from some time. The consumers of the care center are of one persona, and the others who directly go with a per cluster installation and manage things their own way. Things both will continue to exist for some time. We had a lot of people asking for this capability, which is why we sort of thought this could cater to a specific audience and help them get started with chaos. Maybe this is an easy way to sort of break that barrier and start doing experiments because it feels pretty simple to construct these workflows and run them and view what's happening and things like that. Then once you have that familiarity, you probably no longer need this, or you probably just use the API server directly without having to use the dashboard. So yeah, I think both exist.
All right, thank you for that. I think we're seeing this pattern across the cloud native landscape. I know a lot of GitOps tooling now is starting to do that idea of remote management and centralizing your Git operations as well. So I think this ties in really nicely with that approach, especially as we're starting to turn a corner on organizations having lots of small clusters instead of massive large clusters. And the remote management aspect there is appealing and just really getting a lot of steam. So great answer, thank you. Okay, I had.
And on the other question,
yeah, go. No, it's okay. Go for it.
The other question on getting started. So the product docs of Litmus, or as we call it, it's there here. This helps you to get started with Litmus 1.0. It's purely raising the chaos operator, putting the chaos CRs, and executing it in individual clusters, etc. If you are a happy beta tester for Litmus 2.0, you can take a look at the Litmus docs that we have on Netlify. That is the Litmus beta Netlify app. You can go to the master version. You can see a lot of information that's being put here. And this is one of the things that we are at right now, trying to improve the documentation and put in more details of how you can use the Litmus 2.0. Sorry about that. So this is a good place to start, and I would recommend you to take a look at it if you want to get started with Litmus 2.0 in case you just want to run the bare minimal experimentation with the chaos operator. The docs.litmuschaos.io is the one where you get started.
Awesome, thank you for that as well. I have one more question, and then I'll let you jump on to the workflow thing that you said you we were
Yeah.
going to cover. With regards to the data sources, what kind of remote data sources are supported there?
As of today, it is Prometheus
Okay.
that we support. There is a Prometheus exporter in Litmus that is being used well for some time. So you could add a Prometheus data source, start creating panels to view your application behavior. Then you could sort of get Litmus metrics from the same data source and superimpose them against your app metrics to see what's happening to your app during chaos.
Yeah, I think it would be really interesting. So here's my feature request for you now, Karthik. But when we do chaos, I speak from my own experience. I won't say we. When I do chaos engineering, I'm generally trying to see how my app is for customers during terms of turbulence and chaos. And I wonder, if we could have Google Analytics as a data source and be able to actually see, JavaScript rendering time and time to the page being available, the data come down and all that. I think that would be a really interesting insight to how the chaos affects my customer's point of view.
That's a great feature request. I think it makes a lot of sense. Yes, I think that's something that we would be very happy to take on board. Thanks for that feedback. Uh, yes, I think that's
Yeah,
something we should definitely look into.
I'll make sure I open an issue on the GitHub for that. Don't you worry. Okay, do you want to
Yes.
take us away with the
So,
workflow change?
uh,
Oh, sorry, on you go.
on that note, this is where you can create issues on Litmus. So it's like LitmusChaos/Litmus is the repository. Um, Please feel free to create issues here, and we will definitely get back on them and be happy to consider. And feel free to pour your thoughts there on those issues. Really
And of
appreciate
course,
that.
pull
There are some
requests welcome,
discussions
right?
there, so you could start off a new. I mean, you could participate in a discussion, start off a new discussion thread. That works as well.
Nice.
All right. So let's go to the workflow creation part. And before we do that, let me show you what I have. There is an application called as Bank of Anthos, which you might be familiar with, provided by Google Cloud Platform. Very interesting microservices app, has different kinds of services, different platforms being used to create these microservices, Python, I think Java, etc. And they have all the services to give you the experience of a banking app. So you have Bank of Anthos with balance and your ledgers, and has an option for you to deposit funds or make payments, etc. So it's a cool example to get started with for chaos to see what happens. So what we're going to do is we are going to inhibit network traffic on the balance reader app. So that's one of the application, one of the services powering this detail. I'm able to read this balance because of the balance reader. And also when I make payments, it needs to see how much balance we have in our account before it makes the payment. So it tries to speak to this microservice, the payment service, whatever, tries to speak to the balance service. So what we're going to do is create a 100% packet drop. You could call this like a black hole. Basically, nothing goes through to that service, and see how that impacts our experience, how it causes a degradation in the user experience. Let's say I'm a customer of Bank of Anthos, how it impacts me. But with this, we will also see how you can, the intent of this part of the demonstration is to see how you can construct workflows by picking the faults or the experiments from the integrated chaos hub, and how you can set some, how you can tune it for how long you want to run it, etc. So let me go ahead and click on schedule workflow. I'm going to select self agent because the Bank of Anthos resides in the same cluster where my portal is installed on, so happens to be self agent. So let me go ahead and click next. So there are different options here. Some of these might have been, you might have taken a look at them before, but they've been improved underneath, especially the section here on creating new workflow from hub. So in this drop down, I have the Chaos Hub, the single public Chaos Hub that's embedded here. So I basically go ahead and select this and I give it a name. I call it Black of Anthos Black Hole. And I have the option of going and selecting a new experiment. Let me add a new experiment. I'm interested in network loss. So let me select that from this category. I have a filter that you can use. So once I select this, I can go and tune this experiment. So basically click here and I can see details that basically show what hub I've taken the experiment from and what is the name of the experiment and etc. When I say next, I have the option of indicating the application against which we will do this fault. Now this is something like asset discovery. We can call it in other words, just discovering the microservices on your Kubernetes cluster. The agent performs this task, the subscriber to be more precise. So I'm looking at application in default namespace, which is where my Bank of Anthos resides. There are also other namespaces in the system, as you can see. And the balance reader is of kind deployment, and it has an application label called app equals to balance reader. That's the one that I'm going to target. Annotation check here is a way to further do filtering of applications or to increased blast radius control. If you have multiple applications that share a common label, because that's how you deployed it, they were all going to have a common label. You are going to select just one of them for some reason. You can annotate it with a specific annotation, and then you can force Litmus to check for that deployment which carries the annotation before it does chaos, but it's not mandatory. In my case, I just have one instance of balance reader, so I turn the annotation check to false. There's a cleanup policy here which tells me whether I want to keep my pods or I want to clean them. I want to keep them because that's how I can see logs on the portal. The workflow visualization graph in the portal gives you the opportunity to pull the logs for the experiment that is just executed, and it will be able to pick logs from a live or an existing pod on the cluster. We do not store the logs in the chaos center, we just retrieve it on demand. So I would like to keep those pods in order to show you those logs. There are also options to set node selectors. For example, like you may all know, when Litmus executes its fault, it runs it as a Kubernetes job, and you might have preferences on how you want to run this job, where you want to run it, etc. If you have a specific node, there is this practice that's there today where people run business applications on certain nodes. They have dedicated some nodes to run their main application services, either by making use of affinity policies or tolerations and things like that. And they have another node dedicated to running some third-party services or tooling, so to say. In case you're interested in doing that, you can provide the node selector for those details. So let me click next. So at this point, I have the option of adding a probe. Probe is a way to validate steady state hypothesis, and there are different kinds of probes. We will come to that in the next workflow that I run, which is against another service. For now, let me not do any validation. I'm more interested in just running the workflow and seeing the fault. So let me click next, and this is a way for you to tune the duration of your chaos and add any other variables. There are different tunables that a particular experiment supports that you can see in the experiment documentation. So let's say for network loss, you can see that there are different tunables here that you can provide in case you're interested in doing that. Many of them are optional, so you can provide that by adding new keys. And I'm interested in providing just the defaults and running with them. So I click finish. Revert schedule is to keep the chaos resource and not clean it up. This is for the chaos engine resource, which is set to false. And then I go ahead and say next. So this is the step which you might already be aware of to provide the criticality or weight of a particular experiment within a workflow. And this is going to influence the final resiliency score. The points that we provide here multiplied by the success factor of the experiment. The success factor is retrieved as the execution completes. So you have percentage success for that fault, depending upon how many probes were successful or how many native checks within the experiment were successful. When I say native check, it's about, let's say you have a pre-chaos check. I want my services to be in so and so state before I carry out the chaos, because I don't want to do chaos against an already degraded system. And then after you run the fault, maybe there is some particular state you're looking for, and that's a check that you can do. These are called pre and post chaos checks. It's also part of the steady state hypothesis validation. So depending upon how these checks went and how the probes went, even as your fault happens, there's something called as a continuous mode in the probe, which happens in parallel as you do the fault. So it checks real time how your app behaves, not just the recovery, as in the native post chaos checks. So all those checks contribute to you getting a success factor. We call it as a probe success percentage. It's anywhere between 0 to 100%. And that multiplied by the points that you gave for a given experiment, and a summation of this for all the experiments you have within a workflow divided by the total points gives you the resilience score. It's a metric that helps you to understand where you stand with respect to resilience for a particular scenario or workflow for a given app. So this is the one that connects an application or an infrastructure component with a scenario and then tries to tie them together with the score that you have for it. And then that is something you can use because it is quantified. You will be able to compare it over time to see how it has improved or maybe degraded, or you may want to see how it changes across infrastructure. So when you run the same fault against an app deployed in, let's say, a stateful application deployed with a particular storage class on a particular CNI, on a particular type of node, versus when you repeat the same thing with some other environment completely different, you will be able to see some differences sometimes, which are very instructive. So you're learning more about the system that way. So this is going to help in that process. So I'm going to give all the points because there's no real other faults in this workflow, just one. So I just give it all points. I click next. At this point, I can schedule it once or I can schedule it repeatedly. This is standard cron where you go ahead and keep running those workflows again and again. I'm going to just try it once. So at this point, I can view the YAML to see some summary of what is there. The YAML is maybe it may be familiar to you. It might look very much like the R2 workflow it is, just the current workflow. And we have two steps. The first step to install the template for a fault. This describes the fault itself, and it is pulled from the hub that is integrated into the portal. And the next step is to launch the engine, which connects your fault with your application. So you have something here of interest. You can see there is a balance reader in default namespace, and you have the duration here. So we have the drop packet loss percentage. By default, we use or we assume that the cluster is Docker and this is the socket path, but that might be different. You can change it to container D and give it a different socket path, etc. It makes use of the runtime APIs to inject the network fault in this case. Let me finish the flow of the wizard and go to a workflow. So this is going to run, and there will be some pods, transient pods created in your Litmus namespace, which are now doing these tasks of pulling the experiment template from the hub and installing it, and then launching the chaos engine to trigger the actual fault injection. So that can be visualized in this particular visualization graph. There's also a table view that you can use. And as the experiment gets underway, you will be able to see the impact caused on Bank of Anthos. So right now, we're just getting initialized with the actual fault. So and Bank of Anthos looks good. You can see balances all right. I'm able to trade it. I'm able to deposit funds and do all these activities. Very soon, I will not be able to read this balance as the yeah, you can see I made a deposit right now. But I cannot see how much it increased. So that's um, it's not good. You would not like to see these kind of things happen in real time, especially with banks. So the next step, let's say you make payment, you won't be able to make it because you're not able to read the balance. So this has been deliberately set up in a way to not have any. Yeah, you can see the payment failed. It was not able to proceed. In fact, there's a bigger exception that you can see in the logs, and this is something that you would really want to avoid for your applications. So we've deliberately set it up without the right HA and the mitigation. So you will see the error. Let's just illustrate the fault in progress. So we are going to do this. We are going to keep at it for some time, 60 seconds, as you saw in the engine manifest. And once that is over, the balance will be available again. We will stop the chaos or revert it. And you will be able to see that things are restored. And the experiment makes a check to see if it is restored and if it is healthy before it actually concludes. If it finds out that post the chaos injection it was not able to recover, or let's say the self-healing in your infrastructure is not working, then that's a alarm bell, and you will have the notifications to go ahead and check. You can set notifications based on Prometheus metrics, or you can have other means of verifying this. You might have your own observability infra. We have some alerts coming in into the Litmus portal, but that's going to be post to Rawkode. So this is about how your application came up. So let me go ahead and reload the app once again, and I think I should be able to read my balance because the duration has elapsed. Yeah, this looks great. And this is just going to finish its post chaos checks and complete the experiment. You will see there, you will see a pass here in this experiment because it actually ran successfully. The fault ran successfully and the pre and post chaos checks were good. But we did not really validate the behavior of Bank of Anthos as the fault was happening, which I think is pretty important. So in the next workflow that we run, using a different technique, we will upload the YAML file instead of constructing the workflow through the my hub, the portal, the integrated chaos hub. So there we will see the validation intent also added. You can see the logs here. We retain those pods to be able to see the logs. So you will find those details here. The chaos result is the resource that carries details of the chaos. It says probe success percentage is 100. Therefore, and since we have given all 10 points, this was the only fault, you'll have a resilience score of as well. But this doesn't have any validation intent burned in. But you can see some details. There's a history of past of paint runs. So you can repeat this, you'll get some historical information. And you will also have details of, let me just show you that on my console, of the successful injection and revert status of the of your chaos. Let me say describe chaos result. And, looking at the Litmus namespace, you can see there's some information here. This was the application against which we did the chaos, and the status of chaos says reverted, and the kind of application that we actually did the fault into is a pod, happens to be a pod, which most likely it is. Or it could be a node, it could be a disk or an instance, zero instance, whatever. You'll be able to see the current status, which is like generally useful. And there are some events, as you can see here, and also events on the chaos engine resource too. So in case you have some kind of observability around Kubernetes events, you'll be able to track the progress of the experiments that way as well. So that is something you could do, one way of creating workflows. The other way is to create a template. So I could go ahead and schedule workflow, select the agent against which you want to do chaos. Then you could basically select, um, create a new workflow by cloning an existing template. You could go to the individual workflows, the schedules tab, and take a look at all that you ran. And then you go ahead and create a template out of it and provide some name and description. Next time you want to run, you can just pull a previous template, edit it for your needs, and proceed with chaos. That is one simple way of running it. But let's say you want to store it in your Git repository, you could do that. So let me say I set up a Git repository to true, and here I'm just going to provide um, a simple repository on my side. Just call it as this is the repository I'm interested in, and this is public. So you can go ahead and provide that detail and call it as master. That is the branch that I'm interested in. So let me go to Google, and now I have this connect that I will do to this repository. I can provide access token, or I can set up SSH key. Again, I can provide this to my repository. You can just go ahead and provide my SSH keys, and you will be able to go ahead and create or sync workflows here whenever you construct it from your Litmus portal. So that is one quick way of ensuring that there's a golden copy of your workflows in your repository. So you can go ahead and maintain it there. You can change it and get synced into the portal. So in the interest of time, let me move ahead to the next uh, workflow creation type. So here, I'm just going to select the agent, and you can import a workflow from the YAML that you might have in your workspace, on your laptop, or some such location. You can just, or your harness machines, you can just pull that and import your YAML. In this case, I'm going to select um, a chaos workflow that I'm going to use to create or inject fault on an EC2 instance. So this is one of the things that I wanted to sort of highlight in our chaos journey. Um, so a lot of organizations have hybrid environments. Either they are in the process of adopting Kubernetes, migrating to Kubernetes, or they may have already adopted it for some services while they continue to operate some other services out of their so-called legacy infrastructure. It could be EC2, it could be other AWS EC2, or it could be a Google Cloud or Azure, or it could be on their own data centers on VMware. And they would like to do chaos against those components as well, not just targeting pods, doing pod level and node level failures for Kubernetes nodes and pods, but also act against what you call vanilla EC2 instances, if you may. So there are different faults you can do on that. You can do things like taking down the instance or disconnecting disks attached to it, or you can cause some CPU burn or memory burn inside the VM. You can kill processes. You can inject latencies against data networks there. All sorts of you can do service level chaos for services running inside it. VMs, a lot of things that you would want to do there as well, and would want to have the same tooling or location from where you run all that, have the same experience in running chaos against non-Kubernetes entities while you still run the application business logic in Kubernetes. So Litmus is built as a Kubernetes microservices app. So if you take a look at, I think I have, so here it is. Let me go ahead and try to just show you some slides. Yes, here it is. So you can take a look at this. Litmus is going to run on Kubernetes, but it is going to make use of the provider API to do a fault against some cloud infrastructure. As long as it is accessible, if you have set up the access for it using secrets, you will be able to leverage the API provided by these cloud um, platforms. Many of them have well-defined SDK, which you can make use of to launch the chaos. You can either construct a new experiment that way, or you can make use of existing Litmus experiments to do that. This is one such. So we're going to do chaos against one of these instances. So I have some EC2 instances running some application, a Weave scopes. I'm sorry, Weave works SOX shop microservices application, and that is basically hosted on one of these worker nodes. And we're going to bring that down and see what happens to the performance of my sock shop. So this is some chaos happening on my dashboard.
Yeah, it's a
So
funny
far,
Grafana theme.
so let me go ahead and show the last 5 minutes. So we mentioned about steady state hypothesis validation that you'd like to do. So I have the front end service, which is showing me some queries per second, some transactions, 200 ops per second. Maybe this is going to go down when I do the chaos, but I expect it to come back up within a specific period of time. Sometimes you sort of consign yourself to the fact that, okay, there is going to be a dip in performance when we do this, but I'm going to test the mean time to recovery. I'm going to test how quickly my system recovers, how quickly it comes back to good operational state, and my metrics become optimal once again. So we have that kind of a validation we're going to do, along with an availability check to see if the service under question is always available. So those things we want to weave in into the experiment, and for that, let me just take you to this uploaded workflow. So this was another means of running the workflow, or rather constructing it. I have it already, so I've just imported it from my workspace. And then you can go ahead and tune it, same way that you tuned. And if at all you did tune um, something here, either you can do it here, you can do it by editing the YAML, and in case you change something, let's say I want to keep the duration of this not just for 30 seconds but slightly longer, I can choose to do it, let's say I want to do 35. And I want to see what is the latest URL of the Wave Sorts app. And for that, let me try and see what my IP is from the EC2 instances console. So if I look at the detail here, this is my public address. So I'm just going to copy it. I'm going to put it in my I'm just going to change that here, and going to open this up just to see it going down. You open it up here, and you will see the big socks, big socks catalogs appearing here. Now let me go ahead, and now that I've made these changes, you can also take a look at the probes that we have. There's an HTTP probe which is going to continuously verify every 2 seconds to see if I receive a 200 OK on this endpoint. And I'm also doing a performance recovery check within a period of, let's say, there are two retries with 1 second interval. So let's say within a 2 second period, I'm interested, or there's also a timeout here. So each try is going to wait for some time if the response is not found. So within the recovery period, you want specified recovery period, you want the performance to come back to some number, right? It may be met, may not be met. You can see there is a Prometheus endpoint, there's a query that we gave, and then there is a comparator that we have defined. So this you can think of as some kind of service level indicator, SLI, and the cutoff against that can be your service level objective. Sometimes service level objectives might not be as simple as a one microservice metric. It might be a larger data point that you're looking for from your platform, but you would be able to sort of represent that intention, that check around SLOs also using DevOps. So now that we have all this information, let me go ahead and save whatever changes I made here, and then we provide the criticality and just go ahead and execute it. So when we do this, you will see the same couple of steps being performed. You will see the installation of the experiment, and then the chaos engine will be launched to trigger the instance stopping. So here you will be able to see the worker one stopping and eventually go into stop state and stay there for 35 seconds or whatever period we gave it. And you'll also see in the process the application is going to go down, and the metrics are going to drop, and we will be able to make these checks from within the experiment run and give you a verdict and give you a code success percentage that you could sort of make use of for analysis. So let me go and check what is happening. Let me go ahead and yeah, you can see that this is stopping, and it's eventually going to go to stop state. So this is one way of acting upon, you can call an out-of-band way of acting upon cloud resources. But you might also want to do experiments to eat up resources or cause network faults to services running within VMs. And that's something that will be added on. That's also an improvement from last time. We have new experiment categories which make use of agents running within this VM to carry your faults there and give you the infra chaos capabilities in addition to what we already had with, let's say, instance failures or disk failures and things like that. So, yeah, you can see that it is stopped. I will not be able to load WaveSox anymore. And you can do this not just against EC2 instances contributing to a Kubernetes cluster, you can do this on any normal EC2 instance. You can do things by tag, and if you're doing it by tag and you have multiple instances that are identified by that tag, you can provide a percentage of instances that you want to bring down by instance affected percentage. And you can also basically provide a flag for whether the instances that you are killing are part of managed node group or no. If it is, then the recovery or the health post-chaos health checks that we perform will be slightly different. You can see that this is down, and the application is gone down. So this red area that you're seeing here is coming because of the Litmus annotation that we have, the Litmus metric added as a Griffin annotation to tell you that this is when chaos is actually happening. So this is the front end ops going down and sort of coming up, etc. And you will end up seeing the results of those validation. Sometimes your application recovery might be fast, sometimes it might be slow. It really depends on that. And finally, you will have the details presented inside the chaos result what happened to the individual probes, whether they succeeded or failed, and you will be able to get a metric. So there are different kinds of litmus metrics. The awaited experiment is a useful one to show you the period when the chaos ran, and it has injection time and a lot of other details, lot of labels. You can see there is something called context. This is basically details or some metadata of why you're running this particular experiment. You can basically add new labels to your Chaos Engine descriptor, providing information about the purpose of your run, and you will have some of them converted into metric labels on Prometheus in case you want to filter by them. And there are other metrics, notably the experiment wording, which tells you the success or failure of the experiment, and there are some aggregate metrics just to tell you how many have passed or failed in total, just to give you an overall idea. So this is how you go ahead and you can see that this experiment failed as anticipated. The availability check failed, so did the performance checks. So that's something that was expected. So this is a new capability, doing chaos against non-Kubernetes entities, and also being able to do them for both kinds. There are, for example, there is a workflow that you could use to do CPU and memory hog um, from your on your VMs, not so much on pods or Kubernetes nodes. So this is something uh, that can be done as well. You can see there's a reward chaos step in addition to what we had in other experiments to clean up. So let me go ahead and edit this or do an edit YAML and show you increase of this experiment over time. The duration is 60, let me mark it as, let's say, 90. Then it changes, and then go ahead and run this. So all that I'm showing you through the dashboard, all these experiments can be done by directly invoking the chaos engine in the 1.x model of running it with the pure chaos operator. Or if you choose to run with the chaos center, which is what is recommended, you can make use of the APIs to perform these operations. There will be some, we are working on documentation that gives you sample flows, so you could make use of the APIs to run the flows. So that's something that you could do. I also have a Grafana dashboard, and this time we're doing it against this instance called worker 3. I have a node exporter setup, and you will see some utilization spike on the workers here for one of these nodes. So it will take a few minutes for that to come about. Meanwhile, I'd just like to see if there are any questions around these newer capabilities within Litmus, or if there are any questions around what we're going to do next, or maybe what a certain feature is called, etc.
That's a pretty cool new feature. I really like that. So it's nice that you can target those AWS different, kind of vectors rather than sticking purely within the Kubernetes thing. I assume this is something that will be expanded over time to more providers, more clouds, more external resources. Like really, there's no limit to what you can add here, right?
That's true. You can actually take a look at some of the experiments which are in tech review mode. So you'll find them inside your slip, and you can see there are similar experiments from GCP and Azure as well, and for VMware. And like you said, it's not just the instances, there are other services that you can target. So yes, like you said, there's a lot of things that we could add here and make it easy. One of the reasons or one of the advantages of it being purely community collaborated and open source is chaos means different things to different people. So they come with their viewpoints, contribute, and sort of really enrich the library in terms of what all chaos scenarios can be done and what all steady state validations can be done. The hypothesis is something that again is very diverse. It is yep, you can see some spike happening here
Yep.
on the memory and utilization. The hypothesis is again a very interesting concept. Checking the availability of downstream services is one way to think about it. Looking at metrics and performance metrics is one way to look at it. But there are occasions where you would like to see what is the value in a particular field inside of a custom resource. Maybe you're using a Postgres operator and you're monitoring the health of that deployment, and that is reflected in some status field on your CR, and you're interested in looking at that before you do some other things as part of the experiment. That's also part of your hypothesis. So there are different ways of doing checks, and we're also trying to work with on adding these probes, different kinds of probes that you might want to do. Some of them, like Prong Probe, are purely about consuming metrics from Prometheus. There will be other providers that we would like to integrate with to show the interleaving as well as to do validation. But there are other probes that we can build. So all these different modes of doing them, when you do them, etc. So you can actually create. If you look at the principles of chaos here, there are a lot of things which are true, irrespective of the model or the usage environment. It's cloud native, not cloud native. It's great to be able to do validations on steady state. Either you do it manually or build it into the automation, into the experiment. Very real world events do different kind of faults. There's so many kinds of faults possible today, so try and bring them in. Running in production when you're confident and you know the recovery procedures well. You have a sort of sign off from all the stakeholders and run it continuously, because especially this holds so much true for the cloud native world, because there's a constant churn to provide that end user experience. You have your services that you wrote up as an application or service provider, and then there are so many things you're borrowing from the CNCF landscape, from observability, for storage, service meshes, all sorts of things, which are giving you that end experience to the user, or it helps your SRE team to maintain that end user experience in maintaining the health of your deployments. All those things keep changing continuously, so you keep upgrading them. With Kubernetes itself, you keep upgrading, so you would like to know how things change. So it's important to run these experiments continuously and have a framework to automate them. Set up scheduled chaos maybe. And do minimization of last stages, select the right SREs, right component for the right duration, in the right namespace, etc. Have the ability to specify all that. So we're looking at taking these principles and bringing them onto Litmus, along with a few other aids like GitOps and workflows to stitch together scenarios and a few other settings to give you an end-to-end platform for chaos engineering. But there's a lot of improvement that can be made yet in terms of features and in terms of capabilities, because chaos engineering as we speak is evolving. For example, people are venturing into security chaos engineering to find out vulnerabilities. Um, so, in fact, being able to run some services successfully without the right restrictions being placed on running them is also a chaos test. So there are different ways of looking at it. So uh, the scope really, like you mentioned, is endless. There are a lot of capabilities that can be brought in, and we're really looking forward to the feedback and contributions pouring in from the community, and being a CNCF project helps. There's a lot of good feedback that we received over time, which has helped us to make these improvements. And a lot of good contributions coming in from the community. A lot of the probes work was contributed by folks from Red Hat, so which is awesome. And really looking forward to continuing this journey on improving the experiments and the capabilities and hope to be on another um, uh, discussion on Rawkode with more improvements as we go. I
Awesome.
think that's probably takes it to a close on what I had in mind to discuss today.
That was perfect. There are a lot of really cool updates to love there with Litmus. I'm really looking forward to the new version and playing with some of those features. And I love that you kind of almost tied it all together at the end there with the mention of the CNCF and contributions. But we will be doing a contributing to Litmus on Cloud Native TV a week on Friday with one of your colleagues, I believe. So people should check that out if they want to know how to contribute to the Litmus project as well. All right, Karthik, we are at time. I just want to say thank you. That was a really nice look into some of those new features. I think the remote agents are really cool. The workflow improvements, all of that, it's just super cool. And adding on new chaos experiments that go beyond where we already were just opens up so many different potential avenues for breaking Kubernetes, which to me is very exciting. I'm now trying to work out if I can use Litmus for some clustered fun. So lots for stuff for me to experiment with there. Any last words before I let you go for today?
Thank you for this opportunity once again. Really enjoy being on this show and talking about chaos engineering. Looking forward to breaking stuff on Kubernetes and clustered.
Awesome. All right. Well, check out Principles of Chaos. Check out Litmus. Look forward to 2.0. Karthik, thank you again. Have a wonderful day, and I'll see you all soon. Thanks.